Hey guys, it's Lionel. Today we see what the static keyword means in Java. We will see the four cases in which you can use it, which are for variables, methods, blocks, and nested classes. We will see all of this in detail. We will also see why it could be useful and when to use it. In fact, you've probably seen the static keyword used in Java programs before because it's in the declaration of the main method. So, what does it mean? Basically, what it means is that the member declared static doesn't belong to an instance of a class as usual members do. Rather than belonging to an instance, it belongs to the class itself. To make it much clearer, let's create a simple dog class. This class will have an attribute age, which is public. Now, if we come back to our main method, if we want to access this age attribute, what we need to do is declare an instance of a dog object, and then only access the attribute through this instance. If we run our code, we see that the value 0 is printed. Now, if we set the age attribute to 2, for example, and that we run our program, we will see that the value 2 is printed. Now, let's say we wanted to have an ancestor variable that would be equal to wolf. Well, we could simply add it to our dog class and access it the same way we do for the age attribute. However, you might notice that these two variables are not exactly the same. The age attribute is linked to a specific dog or a specific instance of the dog class. However, the ancestor attribute is actually the same for all instances. If we keep it like this, however, the variable will be created for every instance of dog classes, which takes up a bit of memory for no good reason. What we can do to fix this is add the static keyword in our variable declaration. That way, the variable now belongs to the class, and no matter how many instances we declare, the variable will only be once in memory. Now, how can we access the variable? We see that we can still access this through our instance variable. Our program still works, and if we run it, we see that wolf is printed to the console. However, for static variables, it's not how we should access it. The correct way to do it is to access them through the class. In our case, we would write dog with a capital letter, meaning the class name, followed by the ancestor variable. Now, what we could do is actually delete the old dog declaration. Let's run our program and see that everything works. That way, you could actually get the dog ancestor value without need to declare any instance. Another reason to declare a variable static is when the variable should be shared across all instances of a class. Let's say you wanted a count variable that increments by 1 every time a new dog object is instantiated. How would you do that? Well, a way we can achieve this is by declaring a static count variable in our dog class and incrementing it in a constructor. That way, every time a dog object will get instantiated, the count variable will be modified. So, we declare a static count variable and set it to 0. And in the constructor, we increment this count variable. In our main method, let's first print the value of our count variable. It's equal to 0. Now, let's create a dog object and print the count variable again. We see that the value is now 1. If we try it again, we will see that the value will be 2. So, in general, these are the two main reasons to use static variables. For values that are independent of instances, for example, our ancestor variable. The other one is for values that should be shared across all instances, like our count variable. Another useful thing you can do, however, is declare methods static. This can be quite useful for utility libraries, for example. Let's say you wanted a bark method that would only print a message to the console. You could declare it static and therefore use it anywhere in your program without need to declare an instance of the class. Of course, in our example, it doesn't do anything interesting and seems kind of stupid. But take the math library, for example. You could use any of their static methods to execute an operation on a variable without ever need to declare an instance of the math class. For example, you could use their abs method to retrieve the absolute value of a variable. One important thing to note, however, is that static methods cannot access instance variables or instance methods directly. If we wanted to print the value of our age attribute in our static bark method, for example, Java would tell us that we can't access a non-static field from a static context. We've seen that class variables could be static and methods could be static. Another thing that can be static is what's called a static block. These are not seen very often and are only useful when you want to do some processing on static variables right after they are created. For example, let's say we had a static breeds variable which was meant to hold all possible dog breeds. We could declare it in our class, but then we would want to add some values to it. To do this, we could use a static block, and in it, we could add some values to the list. This block will actually be executed only once. That is, the first time the class is loaded into memory. In other words, this will be executed before the constructor, either when the first instance of this class is created, or when the first static variable or static method is called. If we add some print statements to the block and to the constructor, we can actually see the order in which everything happens. If we run our program, we can see that the first thing that is printed is the static block. Then it's the value of the variables, and then only when an instance of the class is created is the constructor called. Of course, we can also see the elements in our breeds variable. For example, we can print the first element to the console. If we run our program, we see that golden retriever is indeed printed. Therefore, the variable did get modified by the static block. The final element that can be declared static is a nested class. A nested class is nothing else than a class that is declared inside another class. For example, we could have a Labrador nested class, which would be declared static. Now, we could have an instance of this Labrador class, and since it's declared static, we don't need to have an instance of the dog class to access it. What this nested class can do is access variables and methods of the outer class that are declared static, even the ones that are declared private. However, it can't access instance variables of the outer class. For example, we could have a print ancestor method in our Labrador class that would print the ancestor static variable of our outer dog class. But what we couldn't do is print the age attribute from this method, because, as we've said, a static nested class can only access static members of its outer class. Other than that, nested static classes behave exactly as a normal top-level class. What it brings is mostly better encapsulation and class or package management. Alright, we've seen static variables, methods, blocks, and nested classes. which is really all there is to know about the static keyword in Java. I really hope I made things clearer. If not, or if you still have questions, feel free to leave them in the comments below. And of course, if it helped, remember to leave a like and subscribe to this channel to be notified of future Java and programming related videos. Thanks for watching. Take care.